If you haven't read the question yet, please pause the video, read the entire question, the beginning, the stem of the question, and then parts A, B, and C, and then play the video again. The hints will make a lot more sense to you. This context involves the stopping distances that are required for a tire that has a new tread pattern. So the average distance is 125 feet. There's the mean of our population. The standard deviation of those stopping distances is 6.5 feet. And the distances are approximately normally distributed in the population. So part A is a review question. You're trying to find the 70th percentile. So you are trying to find, let's review what a percentile means. What you are trying to find is the stopping distance that is so high that at that distance, 70% of cars will stop in a distance that is lower than the one that we have indicated. So we're trying to find that 70th percentile. So this is where you have to use the inverse norm command. So in the inverse norm command, if you put in the percentile, the 0.7, what that's going to do is it's going to give you a z-score. That z-score corresponds to this value right here. So to find that value, you need to use the z-score formula backwards. To find the stopping distance, you need your z-score. To find this distance, then, you're going to subtract the mean, divide by the standard deviation. And that will allow you to solve for the stopping distance that is at the 70th percentile. Now, what's interesting about part B is you don't have to use this distance, but you have to use some of the setup for part A of the question. You're trying to find the probability that at least 2 out of 5 randomly selected cars. So notice I have a fixed number of trials. There are 5. The likelihood that at least 2 cars out of 5 stop in a distance that is greater than the distance calculated in part A. That's this part right here. That's this part right here. So understand, let's let x equal the number of cars out of 5 that need a greater distance. I don't even know what that distance is yet. We haven't calculated that yet. A greater distance to stop. Okay, well, this is a binomial random variable. So there are 2 outcomes. They either do or they don't need a distance greater than the 70th percentile to stop. There's a fixed number of trials. There are 5. There is a fixed probability of success. Your probability of success is 30%. The 70th percentile means that 30% of cars need a greater distance than this distance in order to stop. And the only other assumption here is we have to act as if the stopping distances are independent from car to car. Now, you didn't have to write about those conditions here. You didn't have to write about that here, but the truth is we can act as if that is approximately true. So understand, x is distributed binomially with 5 trials and a success probability of 0.3. So your job is to find the probability that x is at least 2. So at least 2 is greater than or equal to 2. So something to think about here, you can calculate the probabilities using the binomial PDF command of 2, 3, 4, or 5 successes. You can add all of those together, although it might be easier to use the binomial CDF command. Think about the outcomes that you don't want. The outcomes that we don't want here are 1 car, or none of the cars require a distance greater than this distance here. So it might be easier to start with 1 and subtract off the probabilities that you don't want. The binomial CDF command may be really helpful for doing that. And then question number 5. What is the probability that a randomly selected sample of 5 cars will have a mean stopping distance of at least 130 feet? So here, we're only using 5 cars, but the population is already approximately normally distributed. So my sample means are distributed approximately normal with a mean of 125 feet. Now the standard deviation isn't just the 6.5, I have to divide by my sample size of 5. So in this question, you're trying to find the probability then of a mean stopping distance, an x bar, a mean of 5 cars that's at least 130. So up here we used at least also, that's greater than or equal to. So again, this is something where you should be able to successfully calculate a z-score and either use the normal PDF or the normal CDF command to solve for this probability.